So Natalie, yeah, sometimes a teacher's a bit of a dick and they throw something at you that's not fair. But I want you to know that all of science and math really comes down. Notice that there's 5 items here: y2, y1, x2, x1, and m. Usually they give you all of these. And you figure out m. It's pretty easy. But here's my point. When they give you 5 missing items, usually they'll give you 4 of them, and you can come up with the 5th one. Doesn't matter which one's missing. So let me show you. Never panic. In this case, your teacher was a bit mean, and she gave you, let's say, 8. And she told you y2 was, I don't know, let's say 28, 20, let's say 32. She told you y1 was 16. She didn't tell you x2, but she told you x1 was, let's say, 4. Okay? How do you solve it when the missing variable's down there? So she gave you one of the toughest ones. When the missing variable is down in the numerator like this, it cannot be solved if you leave it down there. But essentially, let's take note of this. You've gotten the information for x1 and x2, y1 right here, x1 and y1. 4 is 16, so it's way up here. And you know that x2, you know the y2 is way up here at 32. You just don't know where the x is. Is it here? Is it there? But we know it's up there somewhere. It's above. We also know it's a positive result of m, so we know we're going to go up. So how do we solve it? Well, it can't be left on the denominator like that, and you cannot get it away alone. But any denominator can be removed if you multiply it on the top. So this is called, again, multiplying it by the reciprocal, because it's really multiplying it by this. That over 1. But the rule of math and science is I have to multiply it on the left side as well. What happens on the right side is when you multiply something by a denominator like that, the denominator disappears. The denominator disappears. And now look at that, it's over here on the numerator. So essentially any denominator on the right side of the equation becomes a numerator on the left, or vice versa. Now, I can have 2 things. I can either divide this 8 out of here, or I can just solve this first. 32 minus 16 is obviously 16. And I have a choice. I have 2 choices. I can either divide that 8 out of there right now because it's multiplying this bracket. So I could just easily, again, multiply by the reciprocal because that 8 is timesing the bracket. So I can just divide by 8 on both sides. I like multiplying by the reciprocal. But dividing by 8 has the same solution. Why does it have the same solution? Because multiplying 16 over 1 by 8 over 1 becomes 16 over 8. So you might say, why do that? Why wouldn't I just divide by 8? Because over here it's clearer how to get rid of that 8. But anyway, let's pretend we don't do that. We can also multiply it through like this. So 8 times x2, that's just a unique number. We can call it x now, it's the missing thing. And 4 times 8 is 32, is equal to 16. We're going to add 32 to both sides. 16 plus 32 is indeed 48. We're going to divide both sides by 8. 48 divided by 8 is not a clean number, I don't think. 16, 32, 40... 48, oh, it is, my bad. It is not 8, it is 6. So that means x2 is 6. I also want you to note that I could have divided by 8 on both sides, up here. Or multiplied by the reciprocal, whatever. So just remember that this is multiplying this bracket. So I'm going to divide both sides by 8. It disappears on the right side. That's why I did it. 16 divided by 8 is 2. And now I simply add 4, and I get y2 is 6 again. Same answer. You're always going to get the same answer. If you don't, something's wrong. And going back to our question, we can see that this is definitely true in verification. We go back here and we put 6 in here. We can see, indeed, 32 divided by 16 up here is 16. And 6 minus 4 down here is 2. 16 divided by 2 is 8. You can also sort of guesstimate, like you can kind of say, I know where I'm trying to get because the top comes to 16. And I know that 16 divided by 2 is going to be x equal to 8. So that means this whole thing has to come out to 2. This whole thing has to be equal to 2. And therefore x to 6. You could do it that way, but it's not proper algebra. It's not proper algebra. Yeah, so 16 divided by, 6 minus 4 is 2. This was proper algebra. Now, the same thing works if they're missing x1. And if you're missing y2 instead, it's even easier. Let's pretend we know the answer. This is 32. But we don't. The teacher says, no, you don't know y2. But she does tell you x2. By the way, you can only solve this when there's 4 things available or when there's another equation available. If you're missing 2 variables, you need 2 equations. So how do I solve this? Well, it's clear the bottom comes out to 2. I can multiply both sides by 2. This now becomes 16. It's clear I can add 16 to both sides. And it's clear that y2 is 32. You can see that when it's on the numerator, it's a lot easier. So your teacher was kind of mean by putting on the denominator. However, I want you to be comfortable knowing that this method will work no matter what for solving something.